Everyone, today we are going to learn 5.5 triple integrals in cylindrical and spherical coordinate, right? Okay, so we have a learning objective, and this is a cylindrical coordinate from the chapter 2, right? So we went over this one. We have angle theta from the positive x-axis, and then this is the x-axis, y-axis, and then we parallel with the y-axis. So this is y, right? And then we have hypotenuse r there. And then we have, okay, so basically cylindrical coordinate, we have from the polar coordinate, right? So 2 dimensions, so into the, we have a polar coordinate, right? So that will be r and theta. Then in 3 dimension, we have cylindrical, right? Coordinate, yeah. So we just add z, right? So r theta z, okay? So that's why we have, if we want to convert from the rectangular to cylindrical, can you see? Then we are using x equal to r cosine theta, and then y equal to r sine theta, right? And then z equal to z, yeah? And then when we convert from the cylindrical to rectangular coordinate system, so rectangular means the Cartesian, yeah? Then r squared equal to, then related with xy, right? So x squared plus y squared, tan theta equal to y over x, z equal to z, right? Okay, now triple integration. So this is from double integration, right? So we had experience with the polar coordinate double integration. So we add one more triple. So we have a cylindrical box, and then we add z, right? R theta z. So we are using Riemann sum. Okay, now this is a conversion I rewrite with the handwriting. Okay, so we have Fubinic theorem. So r theta z. So like a double integration, we add r there, right? So does here. So we are using r, but then we add z. Yeah, so double integration, we had this much, but triple integration, we had z. Yeah. All right, so let's do it. We have an example. All right, so this is a region bounded below. So we have region E bounded below by the cone. This is a cone, right? And the equation is z equal to square root of x squared plus y squared. And then above, this is above, right? By paraboloid, which is equation is z equal to 2 minus x squared minus y squared, right? So this is region E. Okay, now we want to find volume at the region, okay? All right, now, then we called, this is the lower bound, upper bound, because this region above, bounded above by this function, below by the cone, right? So this function, okay? All right, now we want to, so for example, all right, so let me rearrange. We have 2 functions. So we make a limit to the function, right? Okay, now when we use a cylindrical coordinate, we have to convert everything, right? So we cannot have xy in terms of xy, right? So in terms of, we have to write down r, theta, z, yeah? Okay, now, this is a lower bound from this function. Then we knew x squared plus y squared, which is r squared. Then we have a square root of r squared, which is r. We get the r from the lower bound. And then upper bound, we have this function. And then we know x squared plus y squared, which is r squared. So we have a 2 minus r squared there. Yeah. So this will be upper limit. This will be lower limit. Okay, so we understand. All right, now, so this is we dealing with the limit respect to z. How about r? Yeah, so how do you find r? So we want to find r. So let's set up z equal to z. Yeah, then we can express z in terms of r. So left z, we said r. Right side of z, we said 2 minus r squared. And then solve for r. Okay, then we can factor out r minus 1, r plus 1. Then we have r equal to 1. And then other solution is r equal to -2, but we do reject because it's about the hypotenuse, right? So in other words, just a radius, yeah? Okay, so it's the length, so we do reject. And then we are using angle theta simply 0 to 2 pi, all right? Okay, so let's set it up. Triple integration. Okay, so let's just set up theta at the end because this one is easily to calculate, right? Okay, then g has the function in terms of r, so it's hard. So let's put the z equal to lower limit, which is r, upper limit, which is 2 minus r squared, right? We had that earlier. And then r equal to from 0 to 1. Okay, now we have to put the r. Okay, so we don't use this function here. We don't use a function. Normally we're using function, right? So we don't use either function, but the either function we are using as a limit because they say the upper bound, lower bound, right? Make sense to you? Okay, all right. Then by the formula, we have to attached insert r and dr d theta dz, yeah? Okay. So dr, but then we follow this limit, right? Okay, so dz first in the case, and dr second, and d theta. Yeah, okay. Now let's integrate with respect to z. Do first, and then treat r as constant, right? Okay, now theta equal to 0 to 2 pi, r equal to 0 to 1. And we have rz, then from z equal to r to 2 minus r squared, right? Then the r, the theta, right? Okay, so we have theta equal to 0, theta equal to 2 pi, and r equal to 0 to 1. R is constant, and 2 minus r squared minus r there, right? The r, the theta. Now we distribute. So that will be theta equal to 0 to 2 pi, r equal to 0 to 1. So let's make 2r minus r squared, change the order, and minus r to the third power, right? Okay, now we do secondly integrate with respect to r. And then there is nothing, theta, right? So I don't write down the treat, blah, blah, blah. So we have a theta equal to 0 to 2 pi. Okay, so we do integrate with respect to r, then we get 2r squared over 2 minus r to the third power over 3 minus r to the fourth power over 4. And then we want to evaluate from 0 to 1. So we have theta equal to 0 to 2 pi. And then we have r squared, no, evaluate, yeah? So 1 minus 1 over 3 minus 1 over 4, locally 0, rest, right? Okay, then what do you get? We calculate everything. So 5 over 12. So 5 over 12 d theta. Then we do integrate with respect to theta. So there will be 5 over 12 theta. We want to evaluate from 0 to 2 pi. Okay, so 5 over 12, 2 pi minus 0, right? Okay, simplify. So we have 5 pi over 6. First example, we studied 2z dr d theta, right? So second part, more complicated. Okay, so let's do the second part for this problem, all right? Okay, so dr, first, we do integrate dr. First means we start the center and move outward the sphere, right? So from the center, move outward. Yeah. Okay. Now, in that case, we separate f of z equal to square root of 3. Okay. So in that case, I notate RZ. So radius and z coordinate 1 and square root of 3 because this is intersecting point of a cylinder and sphere. Intersect the cylinder and the sphere. Okay, so in general, if we indicate the z itself, right? So we start with z equal to 0. Oh, z equal to 0, z equal to 1. Oh, in the case 2, so z equal to 1, z equal to 2, right? But then we have r, so I want to move r equal to, since r equal to 0 here, r equal to 1, approximately here, right? Or 1, and then I want to make a little bit up, or stays, yeah, a little bit up better. So square root of 3, right? Yeah. So a little bit up, square root of 3. Yeah. Okay. So once again, we have to add two regions if we are using the or, the z, the theta. Yeah. So above z equal to square root of 3, that's is the one we want to indicate. So inside the sphere, oh, hold on one second. Inside the sphere, right? Okay, below z equal to square root of 3, inside the cylinder, right? Yeah. Okay, let's do it. We have upper, that will be, we want to use this equation. So x squared, y squared plus z squared equal to 4, right? So let's do it. By the way, I did that first example here, but I don't want to go over. Please read, very straightforward. Okay, so second part. Second part is complicated. So B, so we want to use the R, the Z, the theta. Yeah. So we have the equation x squared plus y squared plus z squared equal to 4. We knew there will be x squared, y squared, which is r squared, right? And plus z squared equal to 4. Now we want to solve for r. So r squared equal to 4 minus z squared. R equal to upper, so we take the only positive, right? So 4 minus z squared. Yeah, take upper, since upper. Okay. Textbook made a mistake. Textbook make r square. We cannot have an r square with an r, right? So we have a z squared. All right. So this one, we set up the radius from 0 to this much. And then z upper. So we will have above z equal to square root of 3 until 2. Yeah. Okay, then the angle theta from the positive x-axis to coming back 2 pi, right? So 0 to 2 pi. Make sense? Okay, now lower, let's do that. R equal to until 1. Yeah, inside the cylinder, right? So R equal to 1. Okay, now Z from Z 0 to square root of 3. Make sense? And then theta, angle pi, angle theta, start the positive angle, a positive x-axis to 1 rotation, which is 2 pi, right? Okay, let's set up that way. All right. So we have that. Oh, by the way, how do we find the square root of 3? Okay, let me show you. We have a cylinder, inside the cylinder, right? So, I mean the cylinder has, this is up here. So cylinder, we have x squared plus y squared equal to 1. So we knew this is r squared equal to 1, right? So then we have r squared plus z squared equal to 4 from here, right? Okay, then r, which is 1 plus z squared equal to 4. Okay, now solve for z. And z squared equal to 4 minus 1, which is a 3, right? Z equal to upper, so we take the only positive, right? So pick since upper. All right. Okay, that's how we get the square root of 3 for the z. All right, so reason 1, which is upper of z equal to square root of 3, right? So that will be r theta z such that r between 0 to, oh, that equation, square root. Okay, let me use it. Let me make smaller. So r is between 0 to square root of 4 minus z squared. Okay, theta we do last. And then z from square root 3 to the top is 2, right? And then theta will be 0 to 2 pi. Okay, now e sub 2 is the lower of z equal to square root of 3. So this one inside the sphere. And then this is inside. Cylinder. So we have r theta z such that r between 0 and 1, right? Inside the cylinder, radius equal to 1, z from 0 to square root 2 over 3, and theta is between 0 to 2 pi, right? Okay. Now we add the 2 reason to get the volume, right? So volume of E, which is theta is the last, 0 to 2 pi. And then G is the second, because we have to make the R, the Z, the theta, right? So G equal to 2. I'm sorry, square root of 3, right? And then R equal to 0 to square root of 4 minus the Z squared. Text made a mistake. And then we do insert R, the R, the Z, the theta, right? We added them. Okay, so angle theta 0 to 2 pi, and then Z equal to 0 to square root 2 of 3, and R equal to 0 to 1, right? And then R, oh, no battery, R, the Z, the theta, right? Look at smaller. The theta. Okay, so let's do that. We want to integrate the first. We want to integrate respect to R first. Okay, so we will have theta equal to 0 to 2 pi, z equal to square root of 3, z equal to 2, r square over 2, and then we want to evaluate 0 to square root of 4 minus z square, right? Plus theta equal to 0 to theta equal to 2 pi, z equal to 0 to square root of 3, and then r square over 2, then r equal to 0 to 1, dz d theta, right? Okay, now theta equal to 0 to 2 pi, z equal to square root of 3, z equal to 2, 1/2. We have a square root of 4 minus z squared, and then the rest is 0. And then I did not write down dz, d theta. Let me just write down dz, d theta plus theta equal to 0 to 2 pi z equal to 0 to square root of 3, 1/2, 1. Oh, luckily, right? So dz, d theta. Okay, left side, theta equal to 0 to 2 pi. And then we do integrate with respect to z. So there's only one variable, the second. And then we do this one, the second. So we will have 1/2. Okay, so this is 4 minus z squared, right? Okay, then means, oh, let's do a little bit worse. So there will be 2 minus 1/2 g squared. Yeah. So we get 2z minus 1/2 g to the third power over 3. And evaluate from z equal to square root of 3, z equal to 2, d theta, plus we have theta equal to 0 to 2 pi, and then 1/2 z, and then we want to evaluate from z equal to 0 to square root of 3, d theta. Yeah. Okay. So let's evaluate. So 2 minus 1/2, 2 cubed over 3 minus 2 square root of 3 minus 1/2 square root of 3 cubed over 3 plus 1/2 square root of 3. Good. And then, theta, crazy right now. Plus theta equal to 0 to theta equal to 2 pi. Theta, right? Okay, now we have to calculate. Can you please calculate this one? All right, so I have this number. I cannot keep the fraction. Yeah, I want to do quickly. So I was using Desmos calculator. So we have a 0.06859. All right, so let's do integrate with respect to theta. So we have 0.06859 theta. We do evaluate from 0 to 2 pi. And then we have square root of 3 over 2. Evaluate from 0 to 2 pi. And we get 0.06859 times 2 pi plus square root of 3 over 2, 2 pi. So simplify, then everything. I have 5.87. Okay, so let's check the answer. Check it out. All right, so I had from the note, so 5.87, the A part. Okay, so this is a 5.87. Yeah, this is more complicated, but we made it. Very good. All right, so let's do spherical coordinate. So this is from 2 point, I don't remember the section number, but we did a cylindrical spherical coordinate in chapter 2, right? Okay, so angle theta is the same as like a cylindrical. So from the positive x-axis, we measure angle theta, right? So we have we read Greek letter phi, right? So this is from positive z-axis, so we measure that. And then we have distance, rho, from the origin to the point P, right? So R, which is the same as cylindrical, right? Yeah. Okay, now converting spherical to rectangular and then rectangular to spherical. So we have this one later too. Okay, let's take a look. So this is a bounded spherical box. So they're using volume, change in rho, and rho times change in phi, 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 phi is uppercase, yeah? And then rho sine phi, and then difference in the angle theta, okay? So this is a volume for spherical bounded box. Okay, so remind some here, right? But take a look, they added, oh, there we go. This is the phi uppercase. This is the phi lowercase. Okay, we added in the spherical coordinate for triple integration rho square sine phi because from the volume we had rho there, rho square, and then sine theta, and then we have delta phi, right? So we are using that. So there we go. Yeah. So this is the function continuous in the spherical box. And then we add like r d z d theta, right? So we add rho square sine phi d rho d theta d phi. Make sense? Okay, now once again, we have a conversion rectangular coordinate to spherical. And then there is a spherical to cylindrical to spherical, and then spherical to cylindrical. And spherical to rectangular, right? And then we went over this one in chapter 2. Okay, let's do this problem. Then we're done. All right? Okay, so we have cone and then hemisphere. Okay, now we have x equal to rho sine phi cosine theta, y equal to rho sine phi sine theta, z equal to rho cosine phi, right? So this is for cone given, right? And let's convert things. So square root of 3x squared, which is rho squared sine square phi cosine square phi theta plus y squared. There will be rho squared sine square phi sine square theta, right? Okay, now, oops. So we can see the cosine square theta and sine square theta there. So there will be square root 3 rho square sine square phi and cosine square theta plus sine square theta. So we can factor out, right? There is comma. All right, we knew that this is one. So that will be, and then one step we can make a square root of 3 and then rho, not square, rho sine phi. Yeah, that's the answer. Okay. Now, we have this technique before, so let z equal to z. So this is a z, right? So we have z equal to square root of 3 rho sine phi equal to what kind of z? So we are using this z here. Yeah. So this z. So rho sine cosine cosine phi. Okay, now we want to solve for phi. Okay. All right, so rho is common, so we divide by rho both sides. So we have a square root of 3 sine phi equal to cosine phi. Okay, now let's divide by cosine phi both sides. And then square root of 3 both sides. So there will be left side, we have a sine phi over cosine phi equal to 1 over square root of 3. Yeah? Okay. So what do you get? Sine phi over cosine phi is tangent phi, right? So tangent phi equal to 1 over square root of 3. Then what's the phi inverse of tangent 1 over square root of 3? Then we should think, right? So then phi equal to pi over 6, since sine pi over 6 over cosine pi over 6, which is 1/2 over square root of 3 over 2, which is 1 over square root of 3, right? Okay, so we are using angle phi from 0 to pi over 6, and then angle theta we will use from 0 to 2 pi. Yeah. Okay, because we measure from positive x-axis, start at 0 to 2 pi. Yeah. And then this will be pi over 6 then. Yeah, pi over 6. Okay. Now, for rho, we have z equal to this one. Yeah, so square root of 4 minus x squared minus y squared. So z equal to square root 4 minus x squared minus y squared. Okay, so solve for rho, right? Yeah, so in order to make a rho, we have to make a x, y, z one side, right? So with the squared, that is a rho squared, right? So there will be square down. So we will get z squared, which is 4 minus x squared minus y squared. And then as I said, we make one side x, y, z with the square down. So x squared plus y squared plus z squared equal to 4. We knew this is rho squared equal to 4. What's the rho? Rho equal to plus minus 2. And then we take the only positive, right? So since upper sphere. All right. All together, let's set it up. Triple integration. So d rho d theta. I'm sorry, d rho d phi d theta. So theta always easy, right? So 0 to 2 pi. And phi equal to 0 to pi over 6. We had that earlier, right? And then rho equal to 0 to 2. So we have to insert rho square sine phi d rho d phi d theta, right? A little bit confusing. Okay, so we want to integrate with respect to rho. Then in that case, we have a phi, right? So phi is constant, right? So do first. So treat phi as constant because we don't have a theta, so I don't have to write down. So we will have a theta equal to 0 to 2 pi, and then phi equal to 0 to pi over 6. Looks like y here, so right. Okay, then rho square, so rho to the third power over 3 sine phi is the constant. So we do evaluate it from 0 to 2 d phi d theta, right? Okay, so that will be theta equal to 0 to 2 pi and phi equal to 0 to pi over 6 sine phi over 3 and 2 to the third power. That's it. Minus 0. Yeah. So d phi d theta. Yeah. Okay, now theta equal to 0 to 2 pi. Now we have 8 over 3 sine phi, phi equal to 0 to pi over 6. And then we want to integrate the respective phi, right? Okay, there's nothing else, so I'm gonna write down just do that. All right, so we have a theta equal to 0 to 2 pi 8 over 3. Okay, what's the integrator of sine phi? Negative cosine phi, right? So negative cosine phi. Almost done. Cosine phi. And then we want to evaluate from phi equal to 0 to pi over 6. All right, so that will be 0 to 2 pi negative 8 over 3 cosine pi over 6 minus cosine 0 and d theta, right? Okay, so what is the cosine pi over 6? What is the cosine 0? So that will be theta equal to 0 to 2 pi negative 8 over 3 cosine pi over 6, which is the square root of 3 over 2, cosine 0, which is 1. Okay, now let's calculate by decimals. So we have a 0.3572 theta, right? Oops, d theta, sorry. Yeah, is it correct? Okay, now we do integrate with respect to theta. So we have a 0.3572 theta. We want to evaluate from 0 to 2 pi. So that will be 0.3572 2 pi. Yeah. So what do you get? 2.24. Okay, so just one problem from the spherical. Okay, all right. Thank you for watching. I will see you in the next video. Thank you. Bye bye.